All right, it's chip of the day. People love chip of the day. It's a Texas Instruments OPA363 is the one we've got. We've got a 363. Let's take a look at which one we got. We have the, here's the little label here stuck down in the box. Let me, can't get it out. I'll get some tweezers here to help me out. Yeah, so this is the one I've got. It is a OPA, it says OPA363 AIDBVR. So whatever that is. I don't know why there's an X there. Mine doesn't have an X. Maybe X, if there's nothing on the X, it means something. I don't know. Anyway, it can operate down to 1.8 volts, which is pretty cool. But it only goes up to 5.5 volts, I think. But it's fast, 7 megahertz, so pretty fast little op amps, 90 dB CMRR, common mode rejection, so that's really good. And then it has a shutdown mode, so it's interesting. Let's jump here to the pinout. So it's a normal single device, so minus and plus V's, but no connection on 1, but pin 8 is enable. Yeah, enable. So you can power this thing down, which is pretty interesting for battery applications. So you might want to think about that. And then when it's in quiescent current, it's only drawing 750 microamps. So very neat. Says you can use it with test equipment and stuff. Here's an application with a microphone going in. They have a pseudo ground. They take 100K and 100K and divide that so they get 2.5 here, and that biases the thing because it's a single supply rail, 5 volts in ground, so you put 2.5 volts as your ground reference, and then you can swing around it with this capacitor. The AC capacitance causes you to be in the happy zone. Everybody wants to be in the happy zone. I know I do. I grew up in Humboldt County. And everybody, if you know anybody who likes marijuana, there's something called Humboldt Homegrown. And I used to be I am a Humboldt Homegrown. But anyway, that's another story. What do we have here? Bias current 1 picoamp. Woo! Yeah, it's a nice little op amp. I have to say, it is a nice little op amp. It's got a cool functional diagram here. V comes in as a regulated charge pump, so it creates this plus 1.8. So it takes the incoming and moves it up a little bit, gives you 1.8 volts more than that, so it gives you headroom so you can do the rail-to-rail stuff, right? So the top here is at VCC plus 1.8 volts, and then you have a current, and then you have a current mirror. The current mirror feeds the input push-pull thing, and yeah, there's another mirror thing on the bottom here. The output looks interesting, though. The output is a bit different than I'm used to. So there's a current here, some diodes over here, some diodes down there. There's a they set up a bias current this way, and these are kind of offset voltages. So you can run this push-pull thing here. I guess it's a standard, class B, class AB type of amplifier. And then the output is totem pole, or not totem pole, but it's push-pull. Yeah, looks pretty nice. What else does the data sheet say? Improving capacitive load, input current protection. Put a resistor on the input. That's always a good idea. I'm going to show you this in a second, but I put a 10K on the input just to make sure that you don't. It's just good habit. Let's just say that. So you can't, even though it says it's 1 picoamps, under certain conditions and stuff, it might be able to draw more current when it's on power up conditions and things like that. And having this resistor there just makes your day happy. Makes it a little bit happy. Happy little resistors. All right. Here it is feeding a A to D, blah, 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 blah. Another application for audio stuff. So audio stuff, yeah, power down application with audio and things. Probably a lot of people use them for that. Microphone preamplifier. I already showed you that one. Here's a cool Salon key. No, it's a Salon key. This is like a gyrator. Active filter gyrator. Oh, that's pretty cool. And then down here we have just a standard, this is like a standard Salon key. This is like a gyrator thing. That's pretty cool. It takes the place of a inductor. I did some videos. Look up that on my web channel. And then this is the standard Salon. Oh yeah, it even says there. It's standard. So look here, yeah, a GIC filter. So it's a gyrator current gyrator. Anyway, it takes the place of the inductor. So you don't need a big inductor. You can just do it with the gyrator. All right, so let's hook one up and get it out here. We'll see how it does. All right, I have one hooked up here in just a non-inverting buffer, non-inverting buffer. So the minus input and the output are tied together. And I'm just feeding it with a sine wave. So we could take a look at it. A little bit of reflection there. I try to minimize that. Oh, that's not going to work, is it? This thing is in the way. That's a little bit better. That's a little bit better. Good enough for the video. Good enough for IMSAI guy. All right. So what we're going to do here is we are going to put the input at 1 megahertz, okay? So we have a 1 megahertz sine wave coming in, and that's the amplitude we're getting. So I have a 2.5 volt offset on the sine wave and a 1 volt signal, and so that's the signal we're getting there at 1 megahertz. Now it says it's a 7 megahertz bandwidth. So let's go here to we'll go half of that. We'll go to 4 megahertz. And you can see I've saved the 1 megahertz sine wave, so it's here. So it is down lower. So yeah, this is probably pretty close to the limit. Usually it's the square root of 2 type of thing, 63% type of thing. Anyway, so that's at 4. Let's look at 7 just to see how it goes. There's probably other limiting factors in that number. Let's see here. Let's go to 7 megahertz. Yeah, see, it's quite low. It is working, but it is quite low on the scale there. All right, that was tip of the day, an OPA363.